All right, good morning. It is morning for me. I don't know what time it is for you. We will be focusing on rotations today, rotation notes. So let's get started. You should have a couple of different colored pens. I'm going to use these two different colors, and I'm going to use a highlighter. So if you have those, pull those out. We're going to first start off with vocabulary. This vocabulary is very important. We have the words clockwise, counterclockwise, turning 90 degrees, 180 degrees, 270 degrees, and origin of 0, 0. So let's see if we can fill in some blanks. The first statement says a rotation is the blank of an image about a point. It is the turning of an image about a point. So we are going to turn now. With reflections, we flipped. With translations, we slid. Now we are turning. In IM1, the point that we will rotate around will always be the origin. And that is 0, 0. The two ways to rotate are clockwise, and we're going to abbreviate that with CW, and counterclockwise, and that is CCW. We will rotate 90 degrees, 180 degrees, or 270 degrees. Those are the three options. 90 degrees, use a different color. 90 degrees is a quarter of a turn. 180 degrees would be a half turn. 270 degrees would be 3/4 of a turn. Okay, so as we come down here, what I want to figure out is we have our y-axis here and our x-axis here. I want to talk about a few things real quick. When we go 90 degrees clockwise, I'm just going to take my paper and I'm do 1/4 of a turn. What happens is my y-axis now changes to my x-axis, and the x-axis becomes the y-axis. So let's rotate back. What would be a comparable 90-degree counterclockwise turn? Well, if we go 90 degrees clockwise here, how would we go counterclockwise in the opposite direction? We would have to go 1, 2, and 3 turns. So 90 degrees clockwise is the same as 270 degrees counterclockwise. If we have that, then we know that 270 degrees clockwise has to be 90 degrees counterclockwise. Now the one in the middle, 180 degrees clockwise. 180 would be 2 turns. That's 180 degrees turning around. And we notice that the y-axis turns back into the y-axis, except it's upside down. And the x-axis turns into the x-axis, except it's opposite sides. And that's important moving forward. I'll explain more about that later. So 180 degrees clockwise, let's see, 1/4 of a turn here, that's 90. Another 1/4 of a turn here, that would be 180 degrees counterclockwise. So 180 degrees clockwise is 180 degrees counterclockwise. And what they're going to tell you is they're just going to say 180 degrees about the origin. Because it doesn't matter whether they are going clockwise or counterclockwise. All right, let's look at some examples that they want us to solve for, or that they want us to rotate. So we've got one example here. It says rotate triangle ABC 270 degrees clockwise. Well, if we think about it this way, that way is clockwise. And if we go to the left backwards, that way is counterclockwise. Okay, so if we're going 270 degrees clockwise, let me see. Nope, didn't want that. Sorry. If going 270 degrees clockwise, that means we're going 3/4 of a turn. So 1/4, 2/4, 3/4 of a turn. And now what I want to do is, in my head, I want to identify what the coordinates of these points are. So A would be, or A prime is going to be -1, 2, 3, 4, -4, -1. B prime, so -4, -1, if I go back to my original, -4, 1, 2, 3, 4, -1, this is going to be A prime. Again, 270 clockwise is the same as 90 counterclockwise, so I'm going to go a little bit quicker. B prime is -1, -1. So I scroll back here, and I find -1, -1, B prime. And then again, 270 clockwise is the same as 90 counterclockwise, so I move my shape, and I find the coordinates of C, -1, -4. I go back to my original, the correct coordinate plane, -1, -4, and that is C prime. I'm going to take a straight edge. I am just using a set of passes. It gives me a nice straight edge. If you have a ruler, an ID card, those work well. I just use what's in front of me. Here we go. So now I have rotated my shape 270 degrees clockwise. For the middle one, it says 180 degrees counterclockwise. Again, we looked up here and it said it didn't really matter if we went clockwise or counterclockwise because we got in the same spot. So let's do the exact same thing as we did on the previous one. I'm going to change colors. So we have W, X, Y, and Z, and I'm going to rotate it 90 degrees, and I'm going to rotate it 180 degrees, and then I'm going to figure out what the points are. So my point for X would be +1, +1. And my point for Y, well, actually, I'm going to do it one at a time. So +1, +1, this is X prime. Rotate again, 90, 180. My Y would be +1, 1, 2, 3, +3. So +1, +3. +1, 1, 2, 3. Y prime. Rotate 180. Now we're getting quick. Get the hang of it. 1, 2, 3, 4. +4, +1 will be W prime. +4, 1, 2, 3, 4, +1, W prime. And then the last one would be Z, which is +4, +3. Oh, sorry. +4, +3. So I'm going to scroll back, rotate back. +4, +3. And then use my straight edge. Ooh. Better job on that one. That one wasn't very straight. Here we go. W, X, Y, Z prime. And we have rotated our shape 180 degrees. What I want you to do is I want you to try the last one, rotating an image 90 degrees clockwise, and then come down here and try and figure out the rules for rotating clockwise. Clockwise 90 degrees. So when you look here, when you have a set of coordinates, what do the coordinates turn into with variables? When you go 180 degrees clockwise, what happens to the X and the X prime? How do they change? When you go 270 clockwise, which is over here, how do the values change between A and A prime? So maybe write down the coordinates and try and figure out how they change and what the rule would be for any rotation of these measures of degree. Have a great day. I would watch this